Okay. So welcome everyone. Welcome to the final session of the final session of the research methods training and certification workshop. It's an honor to welcome you on the last day, and then also to introduce our speakers for the day shortly. So before I do that, I'd like to introduce you to one of our chief mentors of my group, and she's Miss Emmeline Dati, the founder of ICS Africa and then also Level Up Africa. Um, Miss Emmeline Dati would give us a brief message before we transition into the main sessions for today. And thank you for joining on time. And we start now. Thank you. So, without much ado, I'm going to welcome our chief mentor, one of our chief mentors, Miss Emmeline Dati. Thank you, mommy.
Thank you very much, Raphael, and a very good evening, afternoon to you all. I want to first of all congratulate Raphael on this wonderful virtual event he has created, which is very relevant. As somebody who is very passionate about research and policy, I'm very happy that this program came to pass, and I'm hoping it's something that will happen continuously. It is a very much needed course. This area actually is a very profitable and rewarding career because data is now the new gold, okay? And so if you are finding yourself in the area of research, policy analysis, in academia or in industry, then you are definitely going to be in demand and your relevance will never come to an end. But I'd like to fortify this last day by just sharing a few nuggets or a few words with you. How you stand out in the market is very important. The certificate you will get from this session is not what will qualify you. It is you who qualifies the certificate. So I ask you, what are you going to do with what you have learned? What is your vision? What do you want to stand or be known for, to stand out, for? What do you want to be known when it comes to making a difference? How are you going to make a difference with what you are doing? I know probably some of you here may be looking for jobs, looking to upgrade your jobs or whatever, but please remember that everything starts and ends with you. So once you develop yourself, you work on your personal brand, you work on your skills, your competences, that very thing that sets you apart. It's very important that you should know that this is the icing of the cake, but what people really want is your very essence, what you bring to the table. So as you end today, I want you to know that you are already on the road to success. But remember that success has a formula. It doesn't end with certification. It does not end with what you know, but the smart application of what you know. How you apply what you are taught today is what will make you stand out. After today, I'm hoping that you will go further and do more research, learn more, gain more information. Always be hungry for knowledge. Don't stop at the 29th of November. Every day be hungry for knowledge. Set yourself apart. Identify people in your industry that have gone ahead of you and are doing so well. Learn from them, glean from them, serve them, so that you can solidify everything you have learned today. I wish you all well, and I am rooting for all of you. Success is possible. God bless you.
Well, thank you so much. Thank you so much. So how can we express some gratitude with some emojis? We want to show some love. We want to say thank you so much, Mr. Melinda. We are highly grateful for this brief, insightful, and highly motivational and in-depth of knowledge. I think it's something we're going to run with, definitely. And we truly appreciate that you joined. She's very busy and she has to do some more important things, but she still made up the time to join us today. At the end of today's session, we're going to send you um, details and contacts on how to have access to the Level of Africa community. I think it's something that you would never want to miss. And then we'd also share those details with you on the platforms and across the emails as well. So just be on standby. And you want to follow Miss Emalindati on LinkedIn, on Instagram, we will send those details to you as well. Thank you so much for joining, Mom. So we're going to transition to the main session now. And as we do that, are we ready? Can I see some emojis? Can I see some reactions? Are we ready? Awesome, 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 awesome. Yes, we are actively ready. I can see that. Awesome. Okay. So this is the day, and today is going to be super packed. We have a Q&A session, though we know it's not large enough, just to ensure that we manage the time, um, you know, for other participants joining at late hours in their respective countries, and then also for the entire house to respect our time. Um, we ensure that we would ensure that your questions are well attended to. So the ones that probably might not get answered here would be done through other platforms. We would make those means worry form to you as well. So we'll start now. I welcome the moderator for today, the moderator for the first session to introduce our first speaker, and then we get started. And kindly have your mind on the platform. I'll be sharing some documents there for you to make reference to for the second speaker. Thank you. I welcome our moderator, Mr. Richard, to introduce the first speaker. Thank you, thank you.
Thank you, Mr. Raphael. Hello, everyone. Welcome to day 3 of the Research Methods Training and Certification Workshop. My name is Kluche Richard, and I am the Programs Director at the GEMA Group. And it's my privilege to serve as your moderator today. We are extremely fortunate to have with us distinguished speakers whose expertise, insight, and contributions have significantly shaped the field of research methodology across academia and industry. Without wasting my time, I'll move on to introduce our first speaker, who is going to take us through on the topic Mastering Quantitative Data Analysis, Turning Numbers into Meaning. Our first speaker is by name Mr. Godknows Ewuku, who is a PhD student in mathematics at the University of Pennsylvania, specializing in algebraic and applied topology. His research focuses on cellular shapes, advancing mathematical tools for complex systems under the provision of Professor Robert Grist. His work contributes to emerging methods that connect pure topology with real-world data and structural analysis. Let's kindly welcome Mr. Godknows Ewuku.
Thank you very much, Kluche, for that introduction.
You're welcome.
Like you said, my name is Godknows Ewuku. I'm a Ghanaian, but currently doing my PhD in mathematics at the University of Pennsylvania. I would like to use this opportunity to thank Raphael for inviting me to this life-changing experience. I'm really excited to be here and to give a talk on mastering quantitative analysis, quantitative data analysis, turning numbers into meaning. And I believe most of our audience have been through these programs. I've been in this program since Thursday, and you have a great insight from elite personalities and experienced people. So I'm here to do a bit of my side. Okay, so today's talk will be based on turning numbers into meaning, and then we'll have some examples that I will talk about, and I think you should be able to get access to this handout in your respective groups or through email. Okay, so let's start. Why are quantitative data analysis matters? That is a question. So we know in research, we often begin with a question, then we collect data, then it is as a researcher, it is your obligation to actually make something out of the data you have collected, to understand your data in order to answer your research questions. So how do we turn this data full of numbers into clear, honest, and useful conclusions. That is what we are coming to do. Now, quantitative analysis allow us to summarize observation. For example, we can take an example. Most students are satisfied with online learning. So with quantitative analysis, we are allowed to make a statement like that. Or we can be able to test hypothesis. Did the training program actually improve exam scores? Data tells you this information, whether that is true or not, or it also serves as a way to make an informed decisions based on the result that we've gotten from our research questions. Because of this, we need to be very careful as a researchers when you are dealing with data analysis. You do not rush. You have to be very patient and diligent at your work because people may make decisions based on your conclusion, and this decision affects the life of many. Now, what then is quantitative data analysis? So basically, quantitative data analysis is a systematic process of organizing, summarizing, and modeling numeric data to answer a research question or to test a hypothesis. And then quantitative analysis basically have two branches, the descriptive statistic and the inferential statistics. So basically the descriptive statistic just help you exploit what the data that you have collected is telling you. So what is my data saying? The data that I've collected from the field, what is it saying? Then inferential statistics tell you to what extent can I push my result that I've gotten from my sample to a larger population size? So that is the inferential statistics. And this inferential statistics helps you to make some informed decision or to make some interpretation in the context, very important, in the context of your sample. And also you should be very careful to acknowledge your limitation of your sample data that you've collected and the analysis that you are doing. So for this workshop, we'll focus on basic method that you can comfortably implement in Excel, SPSS, and Starter. And also probably I will touch on the use of generative AI or large language model in data analysis because this new emergence of AI is fast approaching, and they are doing incredibly good stuff that you can use them for, especially when it comes to data analysis. But at the same time, you need to be very careful because this AI can make mistakes. You don't need to fully trust what they are saying. You have to double check your work. But then I'll just give a brief talk on that too. Now let's move to our third point. Now, quantitative data analysis, you can see it as a systematic process. It is not a one-touch thing. You have to be very patient. You have to be diligent in working with the data that you have at hand so that you get a meaningful work. So I will take you through about 6 to 7 steps of the workflow that you have to go through whilst dealing with quantitative data analysis or whilst analyzing your data set that you have collected from the field. The first one will be start with a question, check and clean your data, code and recode, exploit descriptively, apply inferential method, and then interpret in the context of your data or in the context of your research questions. So based on these steps, I will actually use an example to explain each and every step. So to illustrate this step, we'll use a practical example, which is evaluating a study skills workshop with data from 100 university students. So this is how the format of our data set is like. We collect the student ID, we collect the agenda category, we record information on the hours studied and whether they attended the workshop or not, and also look at their final exam score. Now, this is the main research questions. Does attending study skill workshop improve students' scores? That is a question we ask ourselves. Does attending students a study skills workshop improve students' exam score? Now, this is our research question. So the first thing we have to do after collecting your data is to redefine the variables in your data. What are the dependent variables? What are the independent variables? What are the covariants or the sort of middle variable that can actually influence your dependent variable? We call them the background variables. So for the purpose of our examples, what we are for the with regard to our example, our dependent variables in this context is the exam score, and then the main predictor based on our research question is the workshop attendance, which is the main independent variables. The other independent variables are gender and hour study. For the sake of what we are doing, let's just consider those are other factors that might be relevant in our questions. Now, after you define your variables, determine which one is the dependent variables and independent variables, you move to cleaning your data. You check and you clean your data. It is very important to have a very high quality of data. I mean, as the saying goes, if you garbage, whatever you garbage in, you get a garbage result. So poor quality data gives you a poor outcome or misleading outcome. So it is very important as a researcher, you make sure you take your time to clean the data. Sometimes we understand it can be so boring and a lot of work. That is why you have to love what you are doing as a researcher. Make sure your data is clean. Make sure you fill in so these are some issues. I mean, some common issues that you can deal with whilst you are cleaning your data. Missing values. For example, maybe some exam scores cells are blank. What do? It's either you fill in or you remove the whole row, depending on your documents. And also there are some values that are impossible. For example, we are considering exam score out of 100. You cannot have something like 150. Just sometimes you may have like something like extra credit, but then you want to have a normal or a standardized sort of markings that you should have throughout in order to actually examine your data as you move forward. And there are values that are very inconsistent. You just know that those values are wrong. You just know in your spirit that these values are very wrong. They cannot be. Example is, for example, the hour study, you are seeing negative values there. You know that this value can never be true. It's either you correct them or you exclude them from your spreadsheet or from your starter or from your SPSS or whatever statistical tools you are using to analyze this data. Then also you have to try to avoid duplications of student ID or student record. Duplication can cause a lot of problems in your data analysis, especially if it comes to descriptive statistics, whilst you are trying to get information from the data that you've collected. So these are just few ones that, I mean, these are just the most common errors that could be in your data that you need to clean up. But then you have to do this very diligently. It's very important. And then always keep a document of your cleaning step. Okay, just keep it as a simple log. This to ensure transparency and reproducibility. I mean, in the near future, you don't know what you might need, and then you needed to reproduce the whole process again. So keeping this document helps you. It helps you keep sort of good record, transparency, and then reproducibility. Now we'll move to the next step, which is code and recode variables. Now this is basically trying to maximize the power of your statistical software. Trying to maximize the power of your statistical software. These statistical software, they are just software. They are very rigid software designed to input result as you to output result as you input data. And they don't understand anything. They don't think. They just follow some systematic approach, unlike AI. So you need to actually maximize their use to make your work efficient, effective, and gives you a high quality result. These are very, very important things. Now, these are some of the examples that you can do whilst you are recoding your variables. Mostly we recode from a binary or a scale kind of level or gender kind of level into a numeric coding where this software will be able to understand and then work with these numbers. Because a software like Excel don't understand what no or yes means, but then they can interpret one and zero. So in place of yes or no, you can just put one and zero on and off. Or for example, if you have a skill that sort of grade the level of disagreement you have with a certain expression, you can just replace all those skills with numbers. Strongly disagree can represent one, strongly agree represent five. And then also, even though we have some variables which already have numbers, but then depending on our research question, we wanted to recode them. For example, exam score. Exam score is a continuous variable from 0 to 100, which is already a number. But then, based on your research questions, you want to know whether the student passed or failed. So you can give us a sort of interval for those who pass and then give a set of interval for those who fail. This is another way of recoding your variable, which is already continuous. And the next one is gender. So this is how you go about recoding your variables. And then one of the most important thing you have to keep in mind whilst you are recoding is to keep a code book. Now, this code book typically tells you how you recoded your variables so that at the end of your analysis, you can go back to your book and bring everything back to the original in order to give a very good interpretation of whatever result you have gotten after the data analysis. So it's very important to keep a code book for how you converted these variables to ensure accurate interpretation. Otherwise, at the end of the day, you recoded your variables and then you probably forgotten. And that could be the worst experience because you have to go back to the whole process again and then analyze your data. So keeping a code book helps you know what you assign to what, the meaning of every variables that you have recoded. The meaning of every variable you have recoded in your analysis. Now, after defining your variables, cleaning your data, and recoding, we come to the main thing, which is the fourth step: explore the descriptive statistics. Okay, explore your data, look at your data. What is your data telling you? You want to derive that information. What is my data telling me? Devoid of external factors. You are not thinking about the research questions. You are not being skewed towards some answer. You are not looking forward for your data to tell you a particular answer. Here you are very open-minded. Just focus on learning what your values or your numbers are telling you. Now, in descriptive statistics or the data that you've collected, you can have categorical variables or numerical variables. And each of these variables determine which particular statistics you apply to it. For example, when you talk about categorical variable, which are gender or workshop attendance, you use frequency, percentages, bar chart, pie chart to actually visualize those variables. But then if you come to numeric variables, you are considering mean, median, standard deviation, minimum or maximum. There are a lot of tools or a lot of statistical formulas that you can use to apply to your data depending on on a particular data that you are dealing with. So the descriptive statistic basically tells you, okay, what is my data telling me? What am I making out of this data? And you have to be very open-minded. Don't be biased, because the research question was not meant to prove a point, was meant to answer a question, whether students who attend a, a study skill workshop exam scores improve or not. So there could be a possibility that this workshop improved the student's exam. There could also be a possibility that it doesn't. So you have to be very, very open-minded when it comes to the descriptive statistics. Now, this descriptive statistics, like I said, tells you information about your data, gives you patterns. What is my data telling me? For example, in our example, the example that I'm using, you realize that the mean exam score for those students who attended the workshop is 67.8. A student who did not had 56.2, which actually gives you sort of some level of insight of what is happening. So you can make a sort of a conclusion. I mean, a brief conclusion. You have to be careful that, okay, students who attended a workshop actually did a bit better. That is just on the surface, depending on your data that you've collected from that particular environment. But then the next question is the difference between this course, is it statistically significant? That is the main question. Is it a true reflection of the fact that they attended the workshop, or is just a chance or some sort of selection bias? That is where the inferential statistics comes in. You have to use other tools to test the significance of this pattern. Is it by chance, or it is actually the impact of steady skill workshop? So descriptive statistics gives you the insight of your data, but the inferential statistics tells you whether this insight you are getting, what is the limit of it? Is it significant or not? And it also helps you to compare. Okay, the students, it also helps you move from what is happening to the sample to what is likely to be true in a wider population. Now, the key is choosing methods that match your research question and variable types. So there are so many inferential methods or tools that you can use to actually check the significance, or to actually affirm the pattern that you are seeing in your descriptive statistic. Now, these tools are mainly based on your variables. Some variables could be categorical, some could be continuous, or both could be categorical, both to be continuous, or some could be multiple independent variables. So in each of these cases, you apply the appropriate tools. So when you're dealing with one categorical, when you're comparing two groups on numeric outcome, you use the independent t-square, where one variable is categorical and the other is continuous. Or if you're having the two variables being categorical, you use the chi-square. For example, in our example, if you want to use a t-square, then you want to compare exam score by workshop attendance. These are different sort of set of data. The exam score is continuous and the workshop attendance is categorical. In this case, you want to use the t-test to actually compare, does the workshop attendance have influence on the exam score? Another one is the chi-square, where you compare two categorical variables. For example, workshop attendance versus pass or fail. This is just pass or fail. These are just a statement, either you pass or you fail. So those who went to the workshop, did they pass? Those who did not go to the workshop, did they fail? What is the data telling you? And the chi-square actually gives a significance or tells you that, oh, okay, whatever result you are getting, it is true or it is not true. And then relation between two numbers. I mean, if the two variables are continuous, then the most common one is the Pearson correlation, correlation, Pearson correlation or Spearman correlation coefficient, or whatever that works best for you. And then where you have multiple independent variables, you use the multiple regression analysis. Now, it's very important to know how to interpret these inferential methods, the chi-square, the t-square. They are very, very important. You need to know how to interpret it, especially the p-values and the confidence interval. And I believe this handout will be given to you, and then details of those things are in the handout, so you can take a look after this. Now, the last step in your workflow or quantitative data analysis workflow is the interpretation. This is very important. Now, we are not only looking at numbers. You should have the ability to interpret the numbers that you are generating from your data. You should be able to interpret. That is where you have to keep note, or you have to document every step of your analysis, so that when you get confused somewhere, you don't get lost into, when you get confused somewhere, you can go back, or when you get lost into these statistical tools or the software, you can go back and know what you are doing. And make sure you don't deviate from your research question. That is the most important thing. You don't deviate from your research question. You are on point with your research question. And then you have to make this clear for people to understand. It's not everybody that understands numbers or statistics. So you have to interpret this in a manner that people will understand what you are talking about. Example of a good interpretation based on our example is that from what we've gotten so far, says students who attended the workshop score on an average 11.6 points higher on the exam than those who did not attend. This is a true value. This is a true statement because that is what we've gotten. Now, this suggests that the workshop may have a positive effect on performance. The point is may have a positive. We are not very certain, but then we are certain that it may have. So because of that, you can go ahead to explore more to understand the qualitative interpretation of these results. However, because our sample was very, very small and drawn from a single university, the results should never be interpreted. The results should be interpreted with caution. Additionally, students who choose to attend may differ systematically from those who did not, which can arise from self-selection bias. So we cannot definitely claim that the workshop caused the improvement. This is just few students picked from one university. So you cannot generalize even this to other universities. You cannot say that, oh, if you run a workshop, then every student in your country scores will improve. This cannot be true because every every school have different resources. They differ in the resources they have available for each of their students. So you need to be very, very careful when you are interpreting your result. Make sure your interpretation is within the sample that you've collected. And you have to be very honest to recognize your limitation. Sometimes you work very hard and you feel like you want to get something big. But that shouldn't be the case because policies will be formed out of your result, and these decisions or these policies affect the life of people. So you need to be very careful. You need to be very diligent and patient, open-minded with your analysis. And then this handout contains some of the ways to use Excel, SPSS, or Stata to run your data. I will not spend so much time on that, but I will I will probably end here and then talk briefly about AI, the use of AI for data analysis. But then the main takeaway from the whole thing that I've talked about is that quantitative analysis bridges raw materials and meaningful funding. So it's sort of a bridge between numbers and then making a meaningful conclusion. Then also it follow a systematic workflow. Okay, it's not just a thing that you just sit one day and press a certain button, then everything pop ups. You start with your research question, collect your data, you define your variables, you clean the data, code your variables, exploit all the statistical tools, descriptive statistics and differential statistics. You test, then you interpret your results. So this is a systematic process, and at every stage, you need to be diligent. And also, you also match your methods to your variables. Every method depends on your variables, whether you're using categorical data or variables versus continuous variables. And also, you have to understand that statistical significance does not mean practical significance. For example, for instance, in our example, where we collect 100 data from, or when we collect data from 100 students in a particular university, and then we realize that, oh, those who attended the workshop has an improvement on their exam score, that does not mean that we should enroll workshop throughout the whole country. And that does not mean if enroll workshop throughout the whole country or territory, we may be able to get the same results. So we need to be very careful about statistical significance and practical significance. And also always interpret your result in the context of your research question and the data or the sample data that you've collected. Acknowledge your limitations. Very, very important. That is what a good researcher do. You acknowledge the limitation of your data. You don't generalize your work. Also, present result clearly, accurately, and ethically. Make sure you have diagrams, you have chart, visualizing tools to make people see it. They don't need to read 100-page document to understand your work. You can summarize this into tables, your scores and everything, your numbers into tables in a nice table in a good format for everybody to be able to make sense out of it. Now, this table should be self-explanatory. They should be self-contained. And then at the end of all this thing, the main goal is to tell a truthful story with numbers. Don't enforce your own biasness on your result because you want something to be true. You try to train the data to achieve that. This is very, very dangerous. Be open-minded. Whatever result that you get, you publish it. Now, if it comes to okay, I'll end here on the talk, especially what is in the handout. But then I'll want to use like 2 minutes to talk about AI. The growth of AI is very exponential, and a lot of corporations are trying to make it available for everybody and to be able to do a lot of things that we find so difficult in our time, especially when it comes to handling large data sets. From my personal experience, these are very, very good. Generative AI, large language model are very, very, very good. In my field of work, like mathematics, I use it 70% of the time for my research because it's so good. it speed up your research, it make your work easier. But then at the same time, these are growing models. They are so young. They are so young, so they have limitation. When they get lost, they don't know whether they are lost or not. They are like kids. So they can tell you something that is not true. They can deceive you or they can mislead you. So whilst they are very good tools, 100%, 70% efficient, but then there is a chunk of subspace that are sort of full of wrong answers, wrong interpretations, and what have you. So whilst it's very good to get exposed to the use of this generative AI, you should also be very careful in the way you try to use them. Uh, Thank you very much for listening. I'll end here.
Wow, wow, wow. That was an insightful session. I'm glad to be part of this, and I hope you are too. Thank you, Mr. Iwuku. We are grateful for sharing with us. Um, Without wasting much time, I'll move on to introduce the second speaker, who is going to speak to us on the topic qualitative data interpretation, making sense of perspectives and narratives. Our second speaker is by name Mr. Benjamin O. Harrison, who is an economic and who is a PhD candidate, economics PhD candidate at Emory University, specializing in econometrics, causal inference, and non-parametric statistics. His work focuses on methodological advances for staged and intermittent treatment designs. He previously worked as a research assistant at the Venice Center for Economics and Risk Analytics after completing a master's in quantitative economics at CA Foscari University of Venice. Ladies and gentlemen, let's kindly welcome Mr. Benjamin O. Harrison to take us through the second session.
Hello, everybody. Can you hear me? Yes. Okay. All right. Thank you so much for having me. Just give me a minute to share my screen. Okay. Can everybody see my screen? Let me see. Yes. Okay. All right. Thank you so much, and thank you, Rachel, for having me, and thank you, Raphael, for also having me. I'm excited to be here. Um, I know that I was supposed to talk about quantitative methods and narrative perspectives and how to make sense of that. Um, but I decided to do something a little bit less traditional. So I am going to talk about project-oriented workflow. And I think this is important because like Owuku, sorry, yeah, like Owuku talk about just recently. Um, when you're doing your research, most 80% or 90% of your research focuses on your either you're doing a quantitative analysis or you're doing a qualitative analysis is focused on that. And that usually includes some thousands lines of codes, which you're going to use to evaluate whatever statistic you're interested in. So you could be running a regression, you could do a hypothesis test, maybe you could do some kind of inferential results. All that is to say that this includes some kind of lines of codes, right? And when you are done with your project or when you're done with this quantitative analysis, you want to have a project that is reproducible, right, and replicable. Reproducible in the sense that if you give your files and your codes to someone, the person should be able to run your code in such a way that he gets the same results as you do, right? If your work is not reproducible, then you don't have like no one will believe you, or it's kind of hard to kind of justify why we should believe your work, right? So your work should be reproducible, right? And so what I'm going to talk about today is basically how do we structure our projects in such a way that we can guarantee or have a reproducible resource, right? And what kind of organizational system, what kind of organizational structure should we adopt? So it's more like some kind of system we should adopt for any kind of project you're working on. And this is not limited to quantitative analysis, and it's not also limited to qualitative analysis. This is like it's very general for any kind of resource, any kind of project you're working on, whether you're doing a master's thesis, whether you're doing a PhD thesis, or whether you are a policymaker or anything like that, right? So that's what I'm going to talk about. Um, yeah. So I hope this turns out to be good because this is my first time I'm also learning this. So all right, perfect. So the outline today is the first thing I'm going to look at is the organizational structure for a project. So how do you organize your projects right from the idea construction to your completed projects, right? Someone is writing on my screen. Okay. Then the next thing we'll talk about will be how to build your quantitative analysis in such a way that it is reproducible and it's also replicable, right? Then we'll connect these two together to create what we call a quantitative pipeline. Okay, so what do we mean by a workflow? Um, so a workflow is basically a system, it's more like an organizational system that basically make your work easier, right? So you don't want to put a strain on your brain to try to remember some idea that you thought about some 3 weeks ago, or maybe you are cleaning your data and you realize that, oh, if I do this, it will make, if I do this thing here, I think it will make my code work, right? And you do that particular thing and you maybe 3 weeks ago, or after 3 weeks, you forget what you did, right? This is what we call a bad workflow. So a bad workflow is basically some kind of a organization system which is not organized, right? So maybe you're trying to look for a particular version of your file and you don't know which version it is. So you have to kind of open each file and to kind of read through to see, is this the version I'm looking for? Or is this the version I'm looking for, right? So all these are kind of things that kind of put a strain on your brain. Like you don't want to waste too much time trying to do that, right? And so you want to have some kind of an organizational system that is kind of easy for you to get things done, right? Or for you to organize your work. And also it's important because sometimes when you're working with other people, this organizational system makes it easier for other people to also follow your work, right? Even for your supervisor as well, right? So if you don't have a good organizational system and you want your supervisor to check your work for you, you will supervisor now have to go through each step to kind of figure out what you're doing, and that will not kind of encourage the person to help you, right? So an example of a bad workflow, like a bad organization system or something like this, and we just kind of have different version of your thesis documents in there, and you have, let's say, thesis final, final, you have thesis final, final, final. Like this is not a very good organization system. So this is kind of a jungle of files. You want something that's more structured, right? And so how do you organize your projects, right? Now, one thing that I should mention is that um sometimes you don't only work on one particular project. So if you are a PhD student like I am, it's possible that you are working on multiple projects at the same time. So you could be working on your own projects, or you could be working on maybe the project of your supervisor. So maybe an area for your supervisor and he has a different project that is ongoing. Or something you could have multiple projects you yourself you're doing because as a PhD student, you have different chapters of your PhD, right? And so it's important for you to figure out how do you organize yourself or how do you organize your project in such a way that you can follow each project's different points in time, right? And so this organizational system here is a particular example of an organizational system in which you have 3 different folders. One folder is for what we call the pending research, the other folder is the ongoing research, and the third folder is the completed research, right? So the pending research is one in which it's more like a hub for your ideas, right? And so if you're like me, sometimes you're taking a walk and you can get some kind of an idea on a particular project, right? So when you get an idea, you kind of write it down, right? You don't want to get an idea and say, "Oh, I'll remember," but you never remember. So it's good to kind of keep track of your ideas, right? And some apps that is useful to keep track of these ideas is like Google Keep is one of them. OneNote is also one of them, right? And also, you don't just want to just keep track of your ideas, but you also want to kind of organize them in a much strategic way, right? And so, for instance, if you have an idea, it's important that you kind of write something about the idea, right? So an idea should have something that it should kind of fill a particular research gap in whatever topic you're interested in. I think Professor I forgot his name, I'm sorry, talked much about this idea or this idea construction or how to fill a research gap, right? And one of the things I would like to point out is that one way to actually get an idea is to read non-academic papers. So non-academic papers could be um, these sustainability reports or maybe some kind of World Bank survey reports on country specific. And even IMF also has some country specific reports in which they normally do on the macroeconomic variable as a whole, right? So all these are kind of reports that you could read that can give you a potential idea or a potential research gap. So when you identify the research gap, an idea is basically what you are trying to do or some kind of a contribution to kind of fill in that research gap, right? And so once you have this kind of idea, it's important to have some kind of a 1 or 2 page um, notes. It could be some kind of an abstraction or it could be some kind of an introduction of what the idea is, the kind of questions trying to fill or identify, or the kind of questions trying to answer, and your contribution to the literature, right? So once the idea has been well developed, they now transition into a project, right? And now you now move that idea, which is now well developed, into an ongoing project. So this ongoing research section or folder could have multiple folders in them, and each folder could be a potential research that you're working on, right? So within that folder, you could have different sections within that folder, which could be a section on your data collection, right? So you also want to in another sense, you want to basically keep track of everything that you're doing at each point in time, right? So when you start your project, maybe the first thing you're going to do is you want to collect the data. You want to keep notes on how you collected the data, the kind of supplement that you use, why did you use that particular supplement. You have to keep track of that and write them down, right? Or keep some kind of a note for them, because when you get to your quantitative aspect of your research, you're going to forget how you did your sampling. You're going to forget how you did your data collection, right? So if you don't keep track of this kind of stuff, it's very hard for you to have something that's reproducible, right? So someone asks you, how did you do your sampling? Now you now have to either go back to everything you've done before and try to locate what you're trying to do, right? So that wastes a lot of time. So tracking or having this organization system helps you a lot. Sometimes we read a lot of papers, especially when you're doing a literature review. It's important to also track of a literature review, right? So keep note of them, use apps such as Zotero or Mendeley. This is important to keep track of your the papers you read and the notes that you take. And this is also helpful when you're doing your references or your citation and stuff like that. Most of the talk today is going to focus on the quantitative aspect of the project, right? When I say quantitative, not necessarily limited to quantitative, but also qualitative as well, right? Now, once your particular project has been done and you think you're ready for publication, then you submit it to the computer research, which could be which means that you are now ready to kind of publish that paper, right? And you can create some kind of a replication package and something that can be ready for journals, right? Also, by the way, stop me if you have a question or stop me if I'm going too fast, right? Okay. So an example of a pipeline or a project pipeline you want to think about is something like this, where you have, so this for a specific project. So in this case, you're looking at your ongoing folder, your ongoing research folder, and you're looking at one specific folder which represents one particular project you're looking at. So within that project, you have maybe you're writing a paper here. So the paper here represents either you're using some kind of a Microsoft Word or you're using some kind of overleaf or a text, some kind of a text document, right? You have some section about your abstract, you have some section about your presentation and blah, blah, blah. And this keeps track of your references, right? Now, within that project, you also have the analysis aspect of it. So the analysis aspect of it could be That could constitute maybe your data cleaning or the data processing or do some kind of statistical, pre-statistical, descriptive statistical methods, right? So maybe looking at the mean, looking at the variances, like what we could just talk about. And so this is just an example of a structure that you want to look at, a pipeline that you want to look at, right? So each folder captures, or each subfolder captures a different section of your project, right? And you don't want to have all the files crumbled in one folder. No, you want to have different folders for different stuff, right? So in this case, you have one particular folder for the analysis, which could be maybe doing your hypothesis test there or your regression there and stuff like that. You have one folder that does the data cleaning and stuff like that, and you have one folder that's where you get your inputs, right? So the input will be where the raw data is, and the output could be maybe your processed data or stuff like that, right? So it's just an example of a pipeline we are looking at, right? But when we talk about reproducibility is normally focused on the quantitative analysis of stuff, right? So that's like where the 90% of your work is, right? So whenever you do your project or whenever you have a research project you're working on, it has to satisfy two conditions, especially if you're aiming for a publishable work, right? If you're aiming for something that can be published in a good journal, most journal now requires that, at least for the past 10 years, most journal require that your work should be reproducible. Reproducible means that if I take your codes and your files and your data, whatever, and give it to somebody or to run on a different computer, I should get the same results as you do in your work, right? And replicability means that if let's say I adapt or change your method or your code a little bit to a different setting. So maybe you did your research on, let's say, in Kumasi or the particular university, and maybe I adapted to a different university, let's say UCC, for instance, right? It should be able, your method should be able to work for me, even though if I get different results, right? Now, this is different from what we could talk about external validity. This is not about external validity. External validity in the case for Oku says that you cannot have the results or the interpretation results for a particular university will be different from the interpretation results from this university because of different kind of stuff, right? This is basically about replicability. Can your code be replicable for a different setting, right? Without too much strain or without too much errors. Okay. So that's the two main key components you want your project to satisfy, right? And the question is, how do we guarantee this? How do we adopt a workflow system that makes reproducibility possible, right? With very minimized error or no error at all, right? Now, this is important, like I talked about, because most journal now requires it. And also, when you're working on multiple projects, you can work on one project maybe for 2 weeks and you move to another project. By the time you come back, you've already forgotten everything. So if you don't have a good workflow system, like things are going to you're going to waste too much time trying to figure out what you were doing and blah blah blah, right? The other thing is that in the world of academia, having co-authors is very important, right? The best way to publish a lot is to work with other people. And if you don't have a good workflow system, it makes collaboration very difficult, right? So these are some kind of important, one of the main reasons why having a good workflow system matters a lot. So there are a few things that you should avoid, and I cannot stress so much on this. You should avoid when you want to have a reproducible work. The first thing is that don't try to when you're processing your data, for instance, we could talk about having this missing data, or maybe you know that the data should have a negative number there, but someone input a negative number there, right? And you want to change that. You should never change it in the raw data file. In other words, don't open your data, the raw data in the Excel file, and go and change it there. When you do that, it is very difficult for you to have a reproducible work, right? You should have a system that allows you to process your data and change stuff, whether you're coding into some kind of a binary system without necessarily hard coding it in your Excel file, right? And so software that allows you to do that easily will be either using an R or Stata or Python or other packages, right? And even if you're doing it in Stata or in R, you should not manually change in the Stata editor or in the data editor. I cannot really stress on this, right? Because once you do this manually, your work is no longer reproducible, right? Because no one knows exactly what the raw data actually is, because you've changed the nature of the raw data. And so in most journals, they require that you have the raw data, what the data looks like even before you catch it, and what your process data is, right? And so you shouldn't manually change your raw data, right? The other thing that you should also avoid is to try to work in sessions or in console. So if you're familiar with Stata on R, remember your Stata has some kind of a command prompt there. You don't do your analysis in a command prompt because it is not something that can be trackable, or you cannot trace it, right? It's better to work in a do file or in a script. If you're using R, it's better to have a script. So the script is basically more like a line of code in which when you execute it, it gives you what your result is looking for, right? And it's always easier to go back and run the script. So we should always work in scripts. And the last thing is naming files. When you're naming documents, you should be careful on how you name files, right? This is not super, super important, especially if you are at the master's level. But if you're kind of working with other people, it's kind of important because it's also even important for you because sometimes it's very difficult for you to figure out which file you were looking at, right? So I will not spend time on this, but I've included some kind of resources here, like the naming guide on how to name your documents, especially depend what kind of document it is. If it's a script, how do you name it? If it's a data, how do you name it, and all that kind of stuff, right? And also, I'm not really going to talk about version control here. So version control is one of the ways that you can actually keep track of your progress, right? Especially at the cloud computing level. So GitHub is one of the best ways to actually keep track of your work. And I won't spend too much time on that. So I've also included a resource here that you can also take a look when you want to learn more about version control, right? So So the question now here is that how do we set up our environment in such a way that we can have a workflow system that is reproducible, right? So I've talked about things that you should avoid doing. I've talked about why you should adopt a workflow that is reproducible. And now we are going to talk about how do we actually set up our environment. So when I say environment here, the environment here will be um, your environment it depends on the kind of software you're working with. So either you're working with Stata or R or Python. I don't know much about SPSS, so I cannot speak about SPSS. I don't know much. I would avoid I would avoid using Excel for your quantitative analysis because it's kind of hard to it doesn't give you a kind of a script, right? So it's kind of hard to keep track of whatever changes you make unless you kind of handwriting it yourself. So I would say the best way is kind of adopt this kind of software like Stata or R, for instance, or Python, which is very useful. And now since we're also in the AI era, you just have to figure out you just have to learn the foundation, right? And ChatGPT can help you to create your code. Of course, you need to know exactly what ChatGPT is doing. That's why you have to kind of have a general idea of some of the functions and stuff like that, right? Okay. Anyway, that was just by the way. Any questions so far? Let me know if you have any questions or if you're good, you can just give me a thumbs up, then I can continue because it looks like I'm just talking to myself. Okay, do you have a question, Shaibu?
Hello.
Yeah,
Yes. Like you were saying, um, in the using uh, the statistical tools, we're expecting to hear like how to administer the EVs and then the uh, other statistical tools. But it's like you veer us to project analysis. So I don't
yes.
know if you can highlight on that aspect for us.
Okay. Um, Okay, thank you. So I think you mentioned EV, so I'm sure you're talking about so if statistical theorem, you're talking about um a particular software for you to do your analysis on, right? So like I mentioned, I think Stata and R, at least for me, are the best statistical tools if you are doing something quantitative. Even if you're doing qualitative, R has a very good what's the name? They has a lot of packages that allows you to have good graphical qualitative results, right? So I would suggest these two packages or these two software, that's Stata and R. Stata is not free, so maybe R will be the best option because R is free, or even Python is also the best option to also learn. eViews is kind of the old version of R in my perspective. So I think you can still use eViews. Um, but I don't know much about eViews, right? So what I'm talking about today is basically a project-oriented workflow, right? So here I'm not really talking about how are you going to code. So maybe how do you code your linear regression, or how do you get the mean of your data or the mean of a particular variable? Um, I think I will put this mention a little bit about that. What I'm talking about is that when you're doing your quantitative analysis, the kind of workflow organization system you should have or you should adopt so that your work becomes reproducible, right? Because at the end of the day, if your work or your research is not something that's reproducible, if it doesn't give you the same results when I run on my computer than when you run your computer, then it's very hard for you to justify your work, right? It's very hard for you to publish your work. And so, it also makes it very easy for you to make a lot of mistakes, right? And so basically that's what we are talking about today, right? I don't know if that answer your question, but we can, if if you want to talk more about maybe certain statistical tools that you are interested in for your work, we can also talk about that after the presentation, right? Okay, I think I'll move on to the environment. So the environment is basically where your analysis live, right? So the first you want to do is that you want to create a particular folder in which you're going to do all your analysis in there, right? And the best way to do that, if you're using R, is to create an R project, right? So I've included a link on how to create an R project. It's very easy. So if you're familiar with R, you just go to your file, you just go to create a new project, you give the name of the project, and you set the directory to where the project lives in, right? Now, for reproducibility, you want to avoid hard coding what we call absolute path. So absolute path is basically where you set your working directory to where it's basically where you want to set. So when you create a folder or when you're working in scripts, you want to basically set a working directory where all your files or your analysis is going to live in, right? And so maybe if you're going to call a particular file, you call it in a particular script and use it in there, right? Now, when you set a working directory like this is my working directory, right? This has my username there, Ben there. That means that if I create my code and I give it to, let's say, Awuku to run it, now Awuku doesn't have this same working directory as me. So when Awuku run my code, given this working directory, Awuku is going to get an error, right? So it means that my work is not reproducible. And so how do we avoid having this kind of errors? Is basically to use what we call a relative path directory. So a relative path is basically means that you put everything in one folder, and basically that folder, when you create that folder, your working directory is specific to that folder. And so that means that if you want to call or save a particular file, a particular script, you save it relative to the root of that folder, right? And this makes your work much more reproducible, right? So it means that if I now take my code and I give it to Oku to run, because I'm using this relative path, it makes it easier. Oku can run it without having any kind of errors, right? So that's the main point. The whole point is that you want to get reproducibility. If you don't have reproducibility, then yeah, that's the key component here. All right. Now, when you also want to get reproducibility, one of the things you also want to do is kind of automate your workflow. When I say automate your workflow, it means that there are some things that you don't want to always keep doing, right? So when you come back to your pro, you don't always want to start from cleaning your data to doing a statistical analysis, then to do linear regression, then to do hypothesis testing. You don't have to start all the way from the scratch, right? That's because sometimes maybe cleaning your data can take a very long time, especially when it's a large number of data sets you're working in, right? So a key component here is to automate your workflow. Automate means that break your workflow into different components so that if I run, let's say I break my workflow into different components, maybe I do my data cleaning first. So the data cleaning aspect is just a line of code that cleans my data, right? When I clean the data, I'm now going to save the process data into a different file, which I call here clean data.rds. That's just an R file name, right? And so now, once I have this clean version of my data, I cannot use this directly to run my analysis without having to go back to always cleaning my data. So that's how you can automate your workflow, right? And so you can do this for different aspects of a project without having to always start from the beginning and running everything from the beginning, right? So at the end of the day, you basically want a pipeline of this form, right? You have maybe different scripts. The first scripts or your first do file will be maybe will focus on maybe just cleaning your data and having some form of process data. So you clean your data and you have this process data here. Then your second script will be your analysis aspect of it. That's where maybe you want to look at the nature of your data set. So you want to maybe run the mean, you want to compute the mean, you want to compute the variance, you want to kind of do some kind of a statistical process. What's the distribution of my data, for instance? How does my data look like? That's where you create a different script like the analysis to do those kind of stuff, right? So that will give you some kind of if you want to look at how your data looks like and all those kind of stuff, or you want to run regression and stuff like that, you do that in the different scripts, right? Then if you want to actually do some kind of plotting, maybe you want to plot your results, you want to print the table, you can do that in a different script, right? That makes your workflow very easy, right? So anytime you go back, you know where everything lives, you know what each script does, and it makes your work also easier. And even if even if you have some kind of errors, it makes it very easy for you to debug your error because you have different scripts that is doing different things. So you know exactly where the error is coming from, right? And so these are some kind of a workflow habit we can adopt, especially if you're working on different multiple projects, right? And so once you have all these different scripts, you can also have what we call the master script. The master script is basically where you put all the other scripts within that master script, and so that when you run the master scripts, it gives you everything, all the results that you need, right? And this is what makes reproducibility easier. So if you read maybe papers in, let's say, Journal of American Economic Journal, for instance, most of them, when you look at their replicate their um replication packages, there's always going to have a master script, and the master script is usually of this form, right? And so it has a particular script that cleans the data, it has a particular script that runs the model, and have the particular script that gives you the figures, right? And so when you run the master script, you get everything, and that's what reproducibility means. And that's what we are aiming for here. Okay. So just to give you some idea, so before your project, before you run anything, you want to actually have this kind of a project setup, right? So within your analysis folder, you have a folder for data. That's where your raw data lives. You have a folder for your script. That's where you create different script that does different stuff, and you have your master file here, right? And so when you run everything, now you should get something like this, right? So within your data folder, you're going to have the process data, and you're going to have some kind of results, and the results are going to give you the figures and all those kind of stuff. So basically, that's what we mean by reproducibility, right? So I'm not really going to talk about how to name files. I've kind of included a link to naming files, which is important, especially for figuring out where your file or specific file lives, or which particular file is doing specific things. Right. So what I've talked about so far is not limited to a particular software. So you can do this either you're using R, either you're using Stata, or either you're using Python. I'm not sure about eViews and I'm not sure about SPSS because I'm not familiar with this too. Also, it also works even for MATLAB, for Julia, for Gauss as well, right? So now, because since I work mostly in R, one of the things that some packages that are very useful when you want a reproducible work, and you don't have to really pay attention to this part of it because it is just for R. But this is just to tell you that reproducibility is kind of also hard to even obtain because even after what we've discussed, or even if you've done all those kind of stuff, there are sometimes when you use a particular package, especially in R, maybe you're using, let's say, ggplot, right? The version of the ggplot you use, unless on my computer, may be different from the version on a different computer because of maybe the version of R I have, right? And when the versions are different, it means that reproducibility becomes kind of difficult because um, behind the scene, we are using different version of the package, right? And so it can lead to different errors. And so one way you can deal with this kind of, one way you can deal with this kind of problem is to be aware of these two main R packages here, which is here. So here is basically an R package which is very useful when you want to create relative path, instead of doing absolute path. And the other package here is the RENV or the RE, and really basically what we call the R environment. This basically keeps tracks of, so when you use this R environment, it basically makes sure that the version of the package I use to run my file is the same version that I will use when I give my code to someone else, right? And so that's very important. So these are some kind of packages you can learn on your own. You can, if you want to really adopt this workflow environment and you want to track your workflow, these are some of the stuff that you want to pay attention to, right? Um, and also I think Stata also have similar things that you can also pay attention to it. So I have included some resources here. So the resources I followed a lot is on Jenny Bryan, which is what they forgot to teach you about R. So this basically talks about this project-oriented workflow, but specific to R environments. If you are familiar with Stata, Julian, Rev also have this workflow environment pretty specific to Stata, right? And I didn't talk about GitHub, I didn't talk about version control, which is also very important. And so I included a resource here that allows you to, if you're interested in that, you can also take a look at Grant's Git lecture on version control and also on GitHub, right? So these are some of the main things I would say is important for you to have, especially if you're a PhD student or especially if you're a master's student and if you're interested in doing research in general and you really want to have research that is publishable, right? Then these are important things that I think you should adapt at your earlier stage of your research, right? I understand that this is a lot of work because already you have to think about a lot on your plate, and adopting this kind of workflow is a huge investment, right? And I think the earlier you have it or the earlier you adopt it, the better for you because it will make your work much, much easier, right? Anyway, thank you for your time. And if you have any other questions, please let me know.
Okay, thank you so much. Thank you so much. Thank you so much. We are highly grateful. So you want to see some emojis in the chat room. Also on YouTube, we are coordinating both platforms. Let's show our presence by sending him some messages, some emojis. And how insightful was this session? Can we rate in the rate of 1 to 10 in the chat room? On YouTube, you can do the same thing. So we see on both platforms. So how insightful in the rate of 1 to 10? When you see some chats. Okay. Okay, 10, 10, 10, 10, 10, and 9. 10 over 10, 10 over 10, 9.999. That is awesome. Thank you so much. Thank you so much. So we want to say thank you to our first two speakers who have already taken the baton, and we'll be switching soon into the Q&A session. It's going to be a panel session where the three speakers would all be available to answer all your questions from the beginning to the very end, that's the last speaker. So now we'll switch briefly into the last presentation, and then we take questions. If you agree with this, can we see some thumbs up? Okay, here we go. So thank you. I would hand over to the moderator to welcome the third speaker for the day. So much, Benjamin. This is awesome.
Thank you very much, Mr. Benjamin. Thank you once again for a very insightful session.
Thank you.
We'll
Thank you
then
so
move
much.
on.
Welcome.
You're welcome. We'll then move on to our final session. And our final session will be on the topic from analysis to publication, writing and presenting research findings. This session is going to be taken by Dr. Nelta Mogwari Monosi. Dr. Nelta Mogwari Monosi is a research-focused real estate scholar whose work bridges academic theory and industry practice. An international grant recipient and Mawazo Fellow, she advances evidence-based studies on African real estate markets. She collaborates with regional authors, contributes to sector literature, and serves on the GREPE board, supporting rigorous research, peer review, and methodological excellence across the field. Ladies and gentlemen, let's humbly welcome Dr. Nelta Mogwari Monosi to take us through the next session.
Thank you so much. And I would like to also thank the organizers. Please just give me a thumbs up if you can hear me, just so I make sure everything is okay. Am I audible and can you see the screen? Okay, perfect. Now can you get started? So what I will be covering today is the from analysis to publication, writing and presenting your research findings. As mentioned, I sit on the board of the Journal of the Real Estate Education and Practice. So I have quite a lot of insight that I'm looking forward to share with you when it comes to how to write your paper for presentation and publication on journals and presenting at conferences. Now, from this session, you should be able to know what the structure of a complete research report or article looks like, be able to apply best practices for writing discussions and conclusion sections of your journal, identify which journals you should look at publishing in and what the journal editors are looking for. Select the journal, navigate through the journal selection and the peer review processes, and along with knowing which mistakes to avoid, which are commonly made by early career researchers. Now, this is the anatomy of a research paper. I want you to think of your research paper as a story. When you're telling a story, there should be a logical flow to it. Now, with a research paper, you have the title and the abstract. With the title and the abstract, it introduces what it is that you're writing about. The abstract gives a summary of the entire paper. So the title and the abstract usually have to be quite strong, because once a person reads an abstract, they immediately think, is this a paper that I'd like to read? So an abstract is very important. And that's why when you see calls for papers, they usually ask you to submit an abstract first before you submit the full paper. So please put your effort into the abstract when you're submitting, especially call for papers for conferences. The abstract will be the one that determines whether they ask you for a full paper or not. Then you have the introduction. This sets the stage, where you have to clearly state what the research gets and what your study is contributing to. Remember, with the research, we are trying to contribute to a body of knowledge. So this is where you are introducing what your paper is going to be and what exactly you are contributing to and how you're doing so. Next, we move on to the literature review. It's a synthesis connecting different studies to show the conversation you're entering, not just a list of who said what. Obviously, with literature review, there are people who have studied a similar topic or a similar research field in which you are a part of. Now, you have to reference, to some extent, the existing literature. And some of the best research papers that come out are the ones that have the relevant literature, but there is a gap that is missing. And this is what your research paper needs to cover. You need to address the existing gap in the literature, state what has been done. So if, for example, I'm in real estate, we're talking about real estate, say, valuations or real estate evaluation methods. State what has been done, state the methodology of valuing a property. Then you state that limited findings or limited research exists in this type of field, and this is what you are trying to fill as a researcher. Then we move on to the methodology. It must be written with enough detail that another researcher could replicate your study. As much as the same way that you are referring to past literature reviews is the same way that other researchers are going to be looking at your research and referencing. If you take a look at platforms such as ResearchGate or ORCID or academia.edu, they are papers that exist that are possibly in your field that you can refer to. And once your papers are published, you usually end up in those platforms. And you can set notifications actually to your emails that show you how many people have cited your paper. Also remember that the stronger your paper, the more citations you'll get, and that will look very, very good on the CV. So let's try and strengthen our research papers as much as possible. In the results section, this is the results/findings. It presents your findings neutrally. You use visuals effectively to support the data, not to decorate. As one of the previous panelists said, the results should be as is. Whatever it is that you have found from your research, the methodology that you implemented, the data that you found, you need to be honest, don't be biased about it. And you need to use visuals to effectively support the data, not to just decorate your paper. Once you have found those results, now we go into the discussion. Yes, you have managed to collect data using, you've managed to analyze or collect the data. Now you have to interpret it. Once you interpret it, now you have to find the results. Given that 1, 2, 3 is what you found, this means that 1, 2, 3. That is how it usually works. Whether it's a qualitative research, whether it's a quantitative or a mixed use, just make sure that the results, the discussion rather, directly addresses what the results and the findings of your paper are. Now, finally, it's the conclusion. This is where you tie everything together. You briefly explain the introduction, literature review, methodology, results, discussion. Then you conclude and you acknowledge the limitations and point to the way forward. Just remember that with every research undertaken, there will always be a limitation. One limitation could be a lack of or a small number of a data collection. So you might have a small sample size. That could be a limitation that can affect your results. And this is something that you can point into to say, one of my limitations was I couldn't find enough participants, and you give suggestions on how you could address those limitations that you faced. And one last thing, please always check the author's guidelines of your target journal before you start writing. It will save you a lot of time. Journals have different requirements. Make sure that it is aligned with your field of study and research. Now let's move on to mastering the discussion and conclusion. This is usually the most challenging. It's quite challenging to discuss your research findings and also structure a good conclusion. The discussion discusses the so what, okay? So you have You have collected your results, you have the results. So what's the point? How do you interpret those results? So for the discussion section, it's what you have to do, interpret results and link them to the theory/literature that you had stated in the literature review and acknowledge the unexpected findings. When you do that, readers will often, what's the word for it? They would actually respect you more for being transparent about the findings, even though you might have thought you would find out that, for example, maybe more women than men like shopping, then surprisingly more men than women like shopping. You need to state that. So be transparent about the findings of your research and the discussion. Don't repeat your results. We have already covered this in the previous section, which is the results section. So make sure that you do not duplicate what you have already covered. So the discussion also answers questions like how do your findings confirm, contradict, or complicate the existing theories? These are the theories that are linked to your research. If it's a gender, which is what I'm focusing on, by different gender theories, there's the feminist theory, there's the ideology theory. How does that confirm, contradict, or complicate these theories? And what are the possible results for the possible reasons for your results? Given that example of if we have more men than women at a shop doing more shopping, what could be the results? The results are, so what could be the reason rather? The reason could be maybe the mall that you are researching on carried more male clothing or more male accessories than women. That's why you find that there are more men in that mall as opposed to women. And what are the real world implications? We are not just, as researchers, we're not just trying to publish. We also want to contribute to the real world. We publish, and then what? How can we take your research and actually be able to apply it to the real world that we live in? And in short, with the conclusion, when making recommendations, they should flow directly from your findings. Avoid grand and supportive statements. Do not be emotional about it. Whatever it is that you find, be specific and use evidence to base your findings on, to base your recommendations on. So I can't just say, oh no, men are more inclined to shop because my husband likes shopping there, so I know that. No. That's not enough evidence. We need to give evidence that no one can question, but if they do question, you are able to back it up, whether it's through the data that you converted into your findings, or if it is the raw data also, whether it's qualitative or quantitative. Once again, state your limitations honestly. It strengthens your credibility and also suggests concrete areas for future research. With the concrete areas for future research, this is not only for you. It can be for other researchers. I could look at, if I'm looking at a paper, say, on land policy, again, I'm in the built environment, I'm in real estate. I look at a paper at land policy and I see the recommendation stating that maybe to strengthen this body of knowledge, let's do 1, 2, 3. That could be an idea for me to write a paper. And this is how you also contribute to the field of knowledge in your area. Now we're moving on to choosing the right journal. How do you choose a journal or a conference? First, does the scope fit your topic? You need to read the recent issues. If it's a call for, say, papers in sustainable development in real estate, it would not make sense for you to submit a paper on sustainable development in the health sector, for example. And also with the calls for the conferences or journals or special editions, they'll usually give you the themes, but these are the themes that we're looking for this particular journal or for this particular conference. Please make sure that you align it with what's in the call for a higher chance of your paper being published. Also, the reputation. Ensure it's peer reviewed and it's a reputable society or publisher. Indexing is very, very important, as well as the audience. Who do you want to reach? Do you want to reach a global audience? Do you want to reach a local audience? Do you want to reach a specialized audience, maybe a specialized industry? In my case, sorry, I just have to keep referring back to my research because it's what I know currently. In my case, I look for journals that are real estate based, whether it's international, whether it's continental, whether it's local. Just make sure that you are choosing the right journal based on your audience and the reputation, scope, as well as indexing. Publishing in a prestigious journal is great, but publishing in the right journal is better. The best fit is one whose scope aligns perfectly with your work. Always check the journal's website for its aims and scopes and look at who they have published recently. Indexing in databases like Scope, as mentioned, or Web of Science is a key indicator of quality. And you can also check what is called the directory of open access journals to see which journals are esteemed, are prestigious, and are also right for you. Be vigilant now, guys. Predatory journal red flags. You will sometimes get, especially when you start publishing slowly but surely, you can get unsolicited emails from certain journals letting you know that, oh, we saw your journal paper on ResearchGate. Please come purchase, come publish in our paper. There's a call. You'll be published immediately. There's a poor website when you look at it. The unclear fees, and sometimes the fees are quite high. And as mentioned, they'll usually come into your spam and they'll be unsolicited. Please, please, please be mindful of these predatory journals, because once you publish in a predatory journal, they sometimes don't even, they don't do peer review. All they want is your money. With publishing, you need to usually pay unless it's open access publishing. So with these type of predatory journals, they'll tell you, okay, to publish your research is $3,000 US. Please don't. Make sure that the journal that you're publishing in or want to publish in is reputable. It'll save you a lot of time, energy, as well as reputation. We're going to quickly look at navigating the peer review process, which is quite daunting. First, of course, like we've been saying, there's a call for submission or a call for abstract. Sometimes there's a call, but they're just other journals that continuously ask for you to submit. You can submit at any day, any time. After you submit, it is given to 2 peer reviewers to look at, and usually there will be 4 feedbacks. Number 1, they'll either tell you that your paper is accepted. Number 2, it's rejected with minor corrections. Number 3, rejected with major corrections or revisions. Number 4, it is outright rejected. After this feedback that you've given, if it's outright rejected, then it's, as I've written here, revisions are an opportunity, not a rejection. And rejection is a part of the journey. Learn from the comments they've given you, improve the paper, and submit elsewhere. In good cases, when you resubmit and they accept, then your paper will be punished. Sorry, published, not published, not punished. Now, in order for you to respond effectively to to rejections or revisions, first, don't take it personally. Be polite, be professional in all correspondence, and write a detailed point-by-point response letter. This is when they give you the feedback. Usually, the feedback will be annotated on your paper. So the reviewers will usually say, no, fix this. This doesn't make sense. Why this methodology? You have to address each and every single one of those. And they'll also sometimes give you corrections paper that makes where you state the corrections that were suggested by the peer reviewer and how you address that. This is where you highlight all the changes that you made in the manuscript. If you disagree, you can provide a reasoned evidence-based argument. I have sometimes I disagreed with what some of the peer reviewers said, and I justified that. After you justify, then they could say, okay, no, that makes sense. And remember, when it comes to writing, it's very hard for you to justify. It's easier for me to explain to you like this when we're talking, right? But if it's in writing, some things may get lost in translation, and this is your opportunity to clarify, especially when they disagree or they're seeking clarity. Just make sure that you give evidence there. Now, this is the sad reality of publishing. There's quite a few number of fortunate writers who will have an acceptance the first time that they submit. Some of us have had to revise, resubmit, revise, resubmit. After you resubmit, there's a new editor, there's a new reviewer, you revise, you resubmit, you wait for 13 months, silence. What I also want to remind you is peer reviewers usually are not paid. As a peer reviewer myself, I am doing this just to just as a voluntary community service actor, but it's also good for your CV. So if there's no response, 13 months, 1 month in, 2 months, and feel free to keep following up with the editors to find out what's happening. Usually they'll be transparent to say we have not found a reviewer yet, but we will inform you once we have found a reviewer. Now, in these moments where there's absolute silence, I would advise you to not wait until you hear something. Get started with writing another paper. Your job as a researcher is to continuously learn and to continuously write. Submit one paper while you're waiting. Start writing on another one. Practical tips for presenting findings. This is more for conferences and for defenses. With defenses, there's some research proposal defenses which are done either verbally or in writing. My research proposal for my PhD, the defense was a verbal presentation, but the final presentation was the final defense was actually just in writing. So different conferences, different institutions have different requirements. You just need to be conversant with all of them. Please know how to defend in writing, know how to defend verbally as well. For conferences, usually it's PowerPoint presentations, as myself and the other panelists have been showing you. Ensure that you use visuals. They should be clear, high contrast, and uncluttered. I believe you have also seen from the other researchers how all the slides are succinct and to the point. No one wants to read your entire thesis or research or journal article in a PowerPoint presentation. Focus more on speaking. Focus more on the message, on the key story, not every data point. The slides, you only use them as a guide. It's not a script. Avoid walls of text and rehearse for timing and confidence. Trust me, we can always tell if you have practiced, if you have revised, and it would not be a good look for you if you have not revised or rehearsed, because it shows that you are not serious about your work. So whether you're confident or not, fake it until you make it. Make sure it's revised. It's within the time that they give you. Maybe they'll say 20 minutes for your presentation, and be as confident as possible. You know your research better than anyone else who will be there listening to it. So make sure you can defend it. They might have some intel into what you are presenting on, but you carried out the research, you analyzed the findings, you know what the findings and the findings are, so confidently present those. In short, the key takeaways is quality communication is key. Excellent analysis is wasted if poorly communicated. Be patient and resilient. As I mentioned, publication is a marathon, not a sprint. You can write maybe five journal articles in a year and only have one published. And it does take a while, as I did show you with the peer review process. Your ethics and transparency are also very important. Make sure you uphold integrity in every step, from writing to data presentation. I'm also glad that the previous speaker, Benjamin, did touch on, I believe it's Benjamin who touched on AI. I'd like for you all to also research a bit on AI hallucinations. So basically what that is there are times when you are using OpenAI, ChatGPT, you say, find me sources for 1, 2, 3, then they'll generate those references or sources. Once you go there, they are not correct because they are just making it up. No, it's just a computer. It's also learning. Please make sure that the references and the sources that you include actually exist and are not a result of the hallucination by whichever ChatGPT OpenAI platform that you're using. And in short, please never stop learning. I myself consider myself to be a lifelong learner. Stay relevant, reinvent yourself, and thrive. I'm glad that we are already sharing our LinkedIn profiles here, and I hope from this workshop you'll be able to collaborate and find someone who is in your research field that you can collaborate on. Thank you so much for your time and for listening. I welcome any questions, and I'll do my best to answer. Please feel free to connect with me on LinkedIn. I believe it's noted on the group as well as on the Zoom chat. I am here to help you if you need assistance. If I can help you, I'll certainly do so. Thank you so much for your time, and over to the moderator.
Thank you so much, Dr. Nota. It's an awesome and detailed session. We are really grateful. So before we do a brief Q&A session, rounding up the entire 3 days in this very impactful final session for you to ask questions from highly experts, in this field of research, all the way from, data analysis, as we earlier started, to publication strategies and tips that you need to know. So if you're ready for that, we want to see some reactions. At the same time, what can we say to Dr. Nelta for this impactful delivery? Thank you so much. Thank you. Okay, so I'm going to call on the moderator for the Q&A session. She's just Lord, and she'll be taking over the Q&A session. If you do have any questions, you may want to, as earlier directed on the platforms, you can lift up your hands using the Zoom feature, the hand raise feature. So we see the list and we call you accordingly. And then also you can send your questions into the chat room as earlier mentioned by Just Lord. And if you're joining us from YouTube, the participants from YouTube, your questions can be directed on WhatsApp to the stated number on the pinned message on the YouTube chat room, or you can just put in the questions there. We will take a screenshot of that and then direct it to the speaker. Thank you, and kindly take over, Just Lord. Thank you.
Thank you so much, Raphael. And thank you very much to all our speakers for such insightful presentation. I want to say a very good evening to everyone once again, and a welcome to day 3 of the Research Methods Training and Certification Workshop. As earlier stated, my name is Just Lodna Aplo, and I am honored to be moderating this session. So now we proceed to our question and answer session. So this session is an opportunity for you to seek any form of clarification or make contributions. If you have a question, kindly use the chat or you can raise your hand and I will duly acknowledge you. Now, to our first question. This is addressed to Mr. God knows. So, Wisdom Zadusa from Malawi wants to know what is the minimum sample size to conduct t-test? Hello, Mr. God knows.
Oh, hello.
Yeah.
Sorry. I thought I've unmute myself. Oh, okay. Generally, there is no single minimum sample size for a thesis, as it depends on factors like effective size, desired power, or data distributions. So, I mean, what's a minimum around probably 10 to 20 per group is often considered a lower limit uh, for a t-test to be valid. But I mean, probably 30 or more, I mean, I would say it's okay for conducting t-sets when assuming a normal distribution or even using two samples t-test.
Okay, thank you so much for your response, Mr. God knows. So moving on, Mr. Benjamin, you also have a question. Someone wants to know if you are more comfortable with one research method over the other, say qualitative over quantitative, should you only use the method you are used to, or should you also try and incorporate the alternative in your research? How do you even determine which research method you should use?
Um, I think the question of choosing either quantitative or qualitative depends on the goal as the researcher, I would say, right? So, for instance, if you want to, it depends on the, okay, one, it depends on the research question you're trying to answer, and two, it depends on what you care about as a researcher. So, for instance, suppose you are interested in, let's say, evaluating the effect of, let's say, free education on particular educational outcome, maybe um what's the results or something like that. In that case, a qualitative analysis is not really will not be the best option to use because that will just give you more like a correlation results. It's just going to tell you, like if you plot, let's say the correlation plot is just going to tell you how the Watson result is basically for moving with the variable that you're interested in, right? And so depending on such a research question, I think a quantitative analysis will be much more viable than a qualitative analysis, right? So I would say it depends on the research question you are trying to answer. And also most of the time you can also combine both the quantitative and the qualitative analysis as well, because the qualitative also gives you some kind of a descriptive measure of the data in general, right? So usually for most empirical work, there's usually what they call the pre-test, in which they do more like a qualitative test of the data. So you can plot, let's say, the distribution of the data, you can plot like, the distribution of the variables, you can look at how each variable is correlated with other, and that also gives you some idea of the power of your analysis, right? And based on this kind of pre-test analysis, it kind of gives you an idea of what kind of a quantitative analysis or quantitative methodology to use, right? So, for instance, um, if you're doing something that requires you to use, let's say, a regression discontinuity methodology in causal inference, in such a setting, you do a qualitative analysis first to look at how your data is distributed, right? Whether do you have a particular cut that can gives you more like an informative idea that I can use this quantitative methodology, right? So that certainly really matters. And I think it depends on the research question, depends on the kind of data you have, and it depends on a lot of factors as well.
Thank you, Mr. Benjamin. So you heard him right. It depends on the type of research question you have. So Stephen, to God knows, he wants to know, can you kindly highlight some AI tools for quantitative analysis, and some visualization tools as well?
Okay. Yeah, I've been trying about 4 of the AIs available. There are a lot available, but then I mostly use like 3 or 4 of them. Grok, Gemini, ChatGPT, and then Claude. If it comes to data analysis, I think Claude recently released a new version, Opus 4.5, that is really great at analyzing data and for visualization. So I would suggest uh, Claude, Claude for data analysis. And also Gemini is okay, but then I've not used it that much for data analysis. So Glock is the best version that I like using when it comes to data analysis and visualization.
Thank you, Mr. Godnose. To the general speakers, any of you can pick it up and then answer duly. So, the audience wants to know, in proposal writing, what common mistakes do you think students make, and how would you suggest they avoid them?
I think I can take that one.
All right.
What in proposal writing, this is for research journals or for thesis or either? Hello, moderator? Hello?
Hello.
Yes, I was asking if it's for thesis or for
For
journals.
thesis is fine.
Okay. Make sure that you need to identify a research gap. You need to identify something that you are passionate about, but also if there is a necessity for it. What gap are you filling? Will you have a hard time collecting data? A proposal should be a gap that you have identified. So make sure or ensure that as much as you're passionate about a topic, there is data available that can support the gap that is there, that you can include in the research proposal. I remember when I did my proposal, it took quite some time because I approached it very naively. I approached it thinking what I have seen without any solid evidence to back it up was enough for me to propose a research that could culminate into a thesis. So just make sure that there is enough data that you can identify and say, okay, there's no data here or there is a gap here. This is the gap that I can fill, and that will make your research proposal stand out and possibly be accepted. I'm sure with a lot of schools, though, they do give you the opportunity to refine your research proposal. Once you do the first proposal defense, they can give you an opportunity to take into consideration what they suggest you should fix or how you can pivot it to make it to ensure that you have a more solid research thesis in the end. I hope that answers your question.
Yeah, it does. It does. But I would have a follow-up to that. I would want to ask you, what best practices do you think students should follow when collecting data ethically?
When collecting data, which?
Yeah, ethically.
Ethically. Can I just ask which research you're in, which field?
Which field I am in?
Yes.
Economics. I have not yet started with my research. I'm asking
Okay.
based on what the audience is asking.
Okay. Sorry about that. There are different requirements. Ethics, for example, you'll find out that the medical field is a little bit more sensitive when it comes to ethics. And also if your research participants are, well, your research, where you're collecting your data, your research sources are human participants, there are some things that you need to make sure that you abide by. This is usually provided by the journal you're submitting to or by the university. For example, I went to the University of Witwatersrand in South Africa. They have ethics documents for research that's conducted with human beings, research that's conducted on pets or animals, just to ensure that it is ethically carried out. It's much easier when it is quantitative. I can't speak much on quantitative as I'm more of a qualitative researcher. So maybe I'll allow the other speakers to chime in when it comes to ethics of quantitative research.
Okay. Mr. God knows, would you like to say anything concerning that?
Oh, can you come with a question again?
Okay. So my question is, when students are collecting data, what could they do ethically to collect the data? Or what best practices can they go through in collecting data ethically?
Um, okay. There are several ways of collecting your data. You just have to make sure that if there is somebody helping you collect the data are not fabricated, and also you make sure you have a well-structured way of collecting your data, not picking data from just putting everything into one basket. And also very important, you have to make sure you protect people, the person or the populations whose data you are collecting. The information you collect on them, you have to keep it private, not to release it to the public. It's very, very important to protect their privacy, especially if they give off their names or locations or address and what have you. And yeah, basically that's what I would say about collecting the data um, to do quantitative analysis.
Okay. Thank you so much, Dr. Nelta, and thank you, Mr. Godnose. So I'll hand over to Raphael in case he has more questions from the YouTube live.
Okay. Yes, please. Thank you so much. We do have a question, and okay, I think before we move into the YouTube, maybe we'll just take one question from the Zoom platform. We have Mr. Mulenga. You can unmute and ask your question. So you direct the question to either of the speaker, and then your name, where you're joining us from, and then your question. Thank you. For audience raised, so we just take one or two. Let's go, Mr. Mulenga.
Good evening, everyone. My name is Kennedy Mlenga, a student of economics at the University of Zambia here in Zambia. And my first question goes to the first presenter. How do you deal with outliers or anomalies in the data? And how do you determine whether they are errors or legitimate? Then the other question is, how do you use data weighing or adjustment techniques? And if so, how will you ensure that these don't introduce biases into your analysis? Thank you.
Okay. Yeah, outliers are bound to happen. Hello, can you hear me?
Yeah, we can hear you.
Yeah.
Sorry, Mulenga, can you kindly mute yourself again? Thank you.
Oh, okay. So outliers are bound to happen in the data, but then there are other statistical means to try to exclude them from your analysis as as possible. I mean, as far as you can, as good as you can, because they make your result biased. So one way to do it is to remove them if they are due to error, or transform the data with techniques, okay, like capping or logarithmic transformation, or use a robust method that are less sensitive to this extreme value, such as, I mean, not using mean, but actually using a median or some other statistical estimators. So we also have another tool called the box and the Quickstar. So it actually helps you restructure your whole data set into outliers, um, into median, mean, and categorize it into percentiles too. So there are other tools that you can search that can help you deal with these outliers. And the next question, sorry, can someone remind me can someone help me with the next question?
Okay. I do have this next question. He thinks that's to me as well. So the second question is, will you be using any data weighting or adjustment techniques? And if so, how will you ensure that this does not introduce biases into your analysis?
Yes. So, I mean, so far, the research that I've been doing, I did not come across a situation where I have to adjust my values. But then the most common one is to normalize your values. And normalization actually does not really affect your result that much. But then it depends on the data that you are handling. And there are a lot of resources which I've added to the handout where you can read on the other method where adjusting these values and how much impact it can have on your data and how to deal with that, whether it is good to adjust your value depending on the data that you are handling. But then one common thing is to normalize your values, which is something common, sort of to have a normal distribution that works best with statistical tools or statistical formulas and what have you. But yeah, I don't know much about other tools and or other techniques and how it may impact your results.
Okay. Yes, please. Thank you so much. Thank you so much. We'll take just um okay, so we'll take just two more questions. So that we can round up briefly, two or three more questions and then we close. Thank you so much, Mr. Goodness. So we have the next hand raised. Mr. Mulinga, if your question has been answered correctly, you can indicate in the chat room so that we be clear. So let's take the next one from Tongo, Alice, and Alex. You can unmute and speak your name, where you're joining from, and then your question. And if it's to all the speakers, just keep it indicated. Thank you. Okay. So you can unmute and ask.
Yes, can you hear me?
Yeah, we can hear you.
Yeah, thank you. My question goes to the last presenter, Dr. Nelha. I would
Okay.
like her to explain for me the anatomy of a review paper that is to be published. Because what was presented was anatomy of a paper that includes data analysis and conclusions and so on. Now, what is the anatomy of a review paper? That's what I want to know from her. Thank you very much.
Okay. Thank you so much.
Sorry,
Yeah,
just clarify that in terms of anatomy. What are we looking at exactly?
He's unmuted. He's muted again. Okay. Sungsitungu, can you come again? So
Yeah,
your
I
name?
wanted to the anatomy of a review paper where one reviews articles, journal articles, and needs to publish. How is the order or the anatomy of that paper? Thank you.
Okay.
The outline of a research paper. Yes,
Yeah, that one, yes.
the outline.
A research
It's
paper, a research paper that is to be published, but someone only review articles without going to the field to collect data. You go to the library, collect articles, and then make a review. How is the outline of such a paper? Yes.
like a secondary research.
Yeah, secondary data research, yeah.
Okay. It's pretty much the same. I think your methodology is the one that will state that it is you collected. It wasn't primary data that you were collecting, but it was secondary data. If I can ask you, please feel free to message me, and then we can talk a little bit more on that, because there are two different types where you're conducting the research from scratch or where you are reviewing. Some it could be you reviewing already existing papers, trying to identify the gap in there or trying to see how it could have been improved. Or in what you're also saying, you can also conduct papers which are just based on, say, government policies that have been published, that are based on articles, other journal articles, or that are on, just trying to think about a couple that I've done that are on white papers, position papers. So you still follow the same guide that I had stated in slide 3, which is the anatomy of a research paper. It just has to be refined slightly, but I'm willing to assist you with that.
Okay, thank you so much. Thank you so much, Dr. Nelta. Let's have just the final two questions, and then we can end for the day. We know that we can take all the questions today. So what we do is we're going to share with you the contacts of all the speakers. You can redirect your questions to them via LinkedIn or email or any other platform available for you to reach out to them. And we would also keep you posted on upcoming series for research training with Professor Minakitan, and then also some sorry, and also our speakers on today's meeting as well. So just be on standby, and also just have your eyes focused on our emails and WhatsApp updates. So let's take just two more questions so we can close for the day and end in a very good. Okay, so we have Dr. Nelta's email there in the chat room. You can copy and reach out to her with your questions as well. Okay, so we'll take the last two questions, one from Hope and then the second one from Augustine. And then we would receive the final announcements, updates on certificates, and other important info you need to know, and then we can call it a day. So before we do that, kindly note that assessment links have been sent on YouTube for all participants on YouTube. Once the YouTube session ends, every live chat is going to be scripted off, so you might not see the link there. So kindly copy the link in anticipation of the end then. And then also for members on Zoom, kindly look into the chat room for the assessment link, and then you'll find it there. I'm going to repost it on both platforms for you to have access to it. So we can go to the next person. We have Hope, Yusuf, your name, where you're joining us from, and then your question. And if it's to all the speakers, just indicate. If it's to one speaker, just indicate as well. Thank you.
Okay, good evening. I'm Hope Yusuf from Nigeria. I am a postgraduate student with the University of Jos Plateau State. I have two questions on publication, and they are to be addressed by Dr. Nelta, please. Sorry. The first one is, what can a researcher do to publish one research in multiple places? Say I have carried out a study and presented it during a conference. Discussions were carried out on that study, and I have made my corrections, and I want to publish it in a journal. It's not necessarily the journal for the organizers of the conference, maybe a university-based journal or a different journal. What can I do? Because if the conference publishes the paper as it was online, and I'm doing it for the second time, the plagiarism checker would take it up and my plagiarism will be very high. So, but they're all written by me. What do I do? How do I go about publishing in two different places? And then the second question is, would you say university-based journals are better for publication than maybe journals for professional bodies or independent journals? Are university-based journals generally better? If not, which one do you think? How do we recognized? How do we recognize better
Yes.
journals to publish
Okay.
in?
Now I
Thank
think
you very
I
much.
think I think I understand your question. So regarding the first one, I'd also just put it in one of the chats I've been having. Conferences, some conferences publish conference proceedings. And the question that was in the chat that I answered had asked if what happens if you take too long for a journal takes too long to respond to you, and it's a requirement for you to have a journal published before you can graduate. In our case, we have conferences that publish conference proceedings, and that's something that you can count as an official publication. When it comes to publishing the same paper in more than one journal, it is usually frowned upon. So if you publish in, say, journal of, in my case, real estate, education and practice, I can't go and publish elsewhere as well. So maybe in this case, what you can do, you can maybe submit your abstract to a few of them and see which one responds first, but you cannot publish in more than one journal. It's frowned upon if they are prestigious journals. And then I think the other question was about, is it better to publish in university journals or journals that are international or outside the school? It depends what your university's policies are. Some universities are very strict about where you can and where you can't publish. This is why I mentioned indexed journals. That's a very important one. If so, for your university, is it open access? Can anyone access your journal if you publish it in your university journal? Do you know? Kindly respond. Do you know if
Yes,
the accessible?
yes.
The
Open
accessible?
access. Yes.
Oh, then it's still fine. If it's open access, then it's going to reach a wider audience, because that's what we're trying to do. Don't just focus on the local or your school only, but try and reach as many people as possible globally. It's not about the prestige, it's about whether it's the right journal for you, as I did state in the presentation. But always check with your supervisor and check with the requirements of the school before you go ahead and publish anything.
Okay. Well, thank you so much. Hope, is the response okay with you? Are you clear?
Yes, I am.
Okay.
Thank you very much.
Thank you. Thank you. So before we take the last hand raised, there's a question directed to Mr. Benjamin. It's from Millicent Moyo from South Africa, from the YouTube platform. And the question is, I am a research student in the construction industry. Is the R, so the R, yeah, I mean the statistical software. Is the R and Python software applicable in my field of research? Can you let me know if I should come again, Mr. Benjamin?
Yeah, I think I got it. Um, I don't know much about construction research, but I think R, Python, these are all just statistical software for mainly quantitative analysis, right? So it can do a range of stuff, right? If you do a lot of, let's say, simulations, which I think most engineering people do, I think R is good for simulations, Python is good for simulations. Anything that has to do with data analysis, I think R, Python is the best. Anything that has to do with, let's say, plotting, doing some kind of qualitative analysis. Maybe you want to plot the distribution of your data. You want to see how, like, what your distribution of the data looks like. This you can use R, you can use Python. If you want to do any kind of if you want to do any kind of, let's say, hard metrics calculations, like maybe computational stuff, maybe you want to do some kind of solve some form of, let's say, optimization problems, or maybe some form of maybe so yeah, some form of either a convex optimization problem or some form of a computation problem. I think you can still use Python, but the best software for that would be, let's say, MATLAB or Gauss or Julia for those kind of stuff. Yeah. So for data analysis and for statistical analysis, I'll stick with R and Python. For computational and for optimization problem, I will stick to Gauss and Julia and MATLAB. And I think also, even in general, Python can do a lot of stuff. And also the good thing about Python is that you can kind of link Python to different software. So you can call packages from, let's say, R to Python. You can call stuff from, let's say, my MATLAB or even Stata to Python. So I think Python is, in general, I would think Python is a good investment to start with, yeah, because it's very, very general for a lot of stuff. Yeah. I think that will be the best.
Okay, yes, please. Thank you so much, Mr. Benjamin. Thank you. So, House, we've come a long way, and personally, I would want to say a big thank you to God for the success of the impact of the 3 days workshop. Would love to take one more question, but because of the time, would like to round it up here. Do you agree with me? If you do agree with me, you can show us some emojis. If you say no, then we take one more. But if you agree, we can just let us know so that we take in your opinions as well into consideration. Okay, thank you. So apparently on this call we do have someone who's joining us all the way from China, and it's past 2 a.m. That's 22 minutes past 2 a.m. currently in the next day, on Sunday. And it shows how much let's say interested you are in this particular training series, and we truly appreciate your interest. We want to say thank you for being through all the way from day one to day two to day three consistently. The consistency is worth it, and we truly appreciate that. Our colleagues joining from India and from all the other platforms. I wish I could mention, I mean, all the other countries. I wish I could mention all these countries, but we did record 34 countries where our participants are joining from. And we want to say thank you, thank you, thank you. We're really grateful you made it, and you made this event a success too. Thank you as well. And to our speakers, to our moderators, to also our partners, to our chief mentors of my group, we are highly grateful. Thank you, everyone. I would like to, before we round up the session straight away, I would like to give us the opportunity to hear one more word from our speakers for today. What would Dr. Nelta have to live with us today as either currently researchers or incoming research pro or experts? And what would Mr. Benjamin want to live with us today? And what would Mr. Godnose want to live with us today? I realized that during the beginning of the session, most of us, not most of us, I'm not part. So some of us were highlighting the fact that the US speakers were speaking too fast. So if maybe you could slow down a bit in response to this, guys, I mean, in your final words for us today. Thank you so much. So we can start with Mr. Godnose, and then Mr. Benjamin, and finally Dr. Nelta, and then we close. Thank you.
Yeah, thank you very much for this opportunity. I'm really excited to be here. And then, yeah, I'm sorry. I just saw in the comment section that I was speaking very, very fast. I was kind of timed. I timed myself, so I don't want to exceed the time that I was working with. So I'm really sorry about that. But then the handout will be out. Everybody, I hope everybody will be able to get access to the handout with detailed information. And there are links to on the handout to for further reading if you want to go into detail of every basic insight. Okay. I mean, it's exciting to do research, knowing that your research one day, even not today, one day will have impact in the life of others. So the fact that you are making the world a better place through your research or trying to add knowledge to the world through your research is very exciting. So you just have to focus, read, and be excited at every opportunity. Never be discouraged because of comments from reviewers. Be happy and then try to learn at every opportunities. You'll be great. Thank you.
Thank you, God knows. Um, so I also will apologize because I think I tend to speak fast in general. So I apologize for that. But like God knows noted, I think the slides, the notes will be available, and there's also some resources that I included if you want to learn more too are also there. Um, so I would say the transition from student to research is hard, especially if you are new to the research field, and it can be very intimidating, and you will get lost at some point, right? Because it's like it's kind of it feels like you are in the jungle and you don't know where to go because there's a whole lot of things and you're just trying to figure out what is the best thing to do, right? And there is no really one way to actually get a completed research. I think you just have to find your own way of dealing with it. And so the transition is hard in general. So I would say that if you're finding it difficult, if you're struggling with it, it's perfectly okay to struggle with it. We all struggle with it. I am also struggling with it. I think it's just natural, right? I would say that I think you should cultivate the habit of talking to people about your research, right? It could be your peers, it could be your friends, it could be your supervisor. If you have an idea which you're not sure, but it's just the first thing you need to do is try to talk to people, try to get people's perspective of the idea, try to figure out is the idea even good to pursue. Um, and once maybe you are certain that this is something that you want to work on, then I think the next aspect was that you have to read a lot. You have to figure out what people have done, and so the whole process is a lot. And so I would say that just take it easy. Don't be too hard on yourself, and everything will be okay eventually. And if you really love what you're doing, even though it is hard, you still find a little bit of satisfaction in what you do, right? And I hope we all I hope you all take some um, motivation from that at least. Anyway, thank you.
Thank you so much. So finally to Dr. Nota, and then we round up.
I think the final words is just to encourage you to always write, always learn, and don't only focus on your research field. Consider interdisciplinary collaborations, which I never used to consider, but I've started slowly incorporating into my research. So you might think you are, say, in an economics field and you are just certain about that particular field, that's all that you want to focus on. But sometimes you can make slightly more impact if you collaborate with other researchers from other disciplines. For instance, I focus on gender in real estate, and I've started incorporating climate change and how it affects that. When I thought about it initially, I didn't think there would be a connection. But through learning, through attending conferences and workshops of the sort, you always see that you can identify a research gap that some people would not have even thought about, that places you, that separates you from the rest of the authors. And academia is very, very, very competitive, guys. It is extremely competitive. And there's a popular saying that says, publish or die. We have to keep publishing, as daunting as it may be. You're probably going to get more rejections than acceptances. but with publishing, with writing comes practice, and you perfect it. You're going to develop your own writing style. Don't try and write like someone you idolize or someone you look up to who is a seasoned researcher. Make sure that your writing style stays yours. And I have had incidences where a peer reviewer would be like, I don't like the style of writing. Maybe she should change it. But you don't have to change it as long as you're communicating the message that you're trying to get across. Maintain your individuality, keep collaborating, find a mentor most importantly. And I'm also here if you need me. Please feel free to drop me a message. I'm more active on LinkedIn, so we can communicate there. Let's look at collaborating, not only within your countries, but also with other professionals or researchers throughout the continent and throughout the globe. It will definitely expose you to a lot more, to a larger audience that could benefit you, and you will get to travel the world, usually fully paid for if you do manage to get research funding or win grants. So all the best. I am here, and thank you once again to the organizers. Thank you to the other panelists. I have also learned a lot, and I hope I do also get my certificate of participation. Thank you so much, Raphael, for inviting me to participate. Thank you.
Thank you, thank you, thank you. So this is the last session, and if you are happy to be here through to the end, you want to show me some emojis, want to show me some reactions, some text in the chat room. And then what can we say to our speakers today? It's been great to listen to a lot of insights from Dr. Nelta. She's an academic and practice researcher, Tempest Gold properties, and then also Godno Sawoku, PhD student, University of Pennsylvania, and Benjamin Harrison, PhD candidate, Emory University in the States. We are so glad to have this insightful session, and thank you all for making it from day one to day two to day three. Words would not be enough to explain, but we thank God and we thank you and we thank our speakers. And then also on behalf of my group, we want to say a big thanks. And then also a big thank you to our partners, and then also to our chief mentors of my group. Thank you for making it. We're so glad. And so for updates, information on this, you'll likely be receiving your certificates in the course of next week. So the week after this coming week. So within the space of this coming week, we're going to review all the assessments that were submitted, and just to ensure that there's transparency through the process. And then your certificates should be distributed from the upper week. So we will keep you posted on all information you need to know on the WhatsApp platform and via email. And then finally, details on the contacts of the speakers, all the facilitators, and also contacts of our partners and other important information that we know you need to take advantage of would be shared with you on our platforms as well. So kindly don't leave the WhatsApp platform. Stay still and then be on standby for very important updates. Thank you, and we can call it a night here. Goodbye, everyone, and thank you for joining. A big thank you to our moderators for today, Lord and Richard. Thank you. Thank you. Bye, everyone.